Okay, well, here we go. Addition of rational expressions with unequal denominators. It's a pretty straightforward lesson. We talked about uh, adding fractions before, so let's just remind ourselves of one uh, important rule with fractions. Actually, two important rules. First of all, any fraction where the numerator and denominator are equal, but not equal to zero, evaluates to one, right? Everybody knows that. 4/4 is 1. 3/3 is 1. X over X is 1 as long as X doesn't equal 0. So you guys, we've done this 1,000 times before. You know this, okay? And then the second part of this fraction rule is multiplying any fraction or other number by 1 does not change the value of the fraction. So if you multiply anything by 1, 10 times 1 is 1. 500 times 1 is 500. X times 1 is X. As long as you're multiplying by 1, it does not change the value of the fraction. And 1 can look like any number over itself in fraction form. So we'll combine these two rules together in order to help solve these problems. So here we have two problems. We'll just do one at a time. Let's start with the left. You have X over Y, and then plus 3 over the quantity X plus Y. And so in this case, let's add. So what do we do first when we're adding fractions? Anyone?
Make the denominator equal.
Yeah, common denominator. Anyone have an idea what a common denominator might be for this one?
X plus
Plus
Y.
Well,
Jinx.
it's actually y times x plus y. So one way you can always get a common denominator is to multiply all the denominators together. And then it will be common because they'll all be factors of that number. Sometimes you might get a much bigger denominator than you have to, which is why a least common denominator is a thing. But you can always multiply two things together to get a common denominator. So in this case, y times the quantity x plus y. So now let's multiply the x times y, or x over y, sorry, by a fraction that's equivalent to 1 that will get us that common denominator. What's it missing from y times x plus y? It's missing x plus y. So if we multiply it by x plus y over x plus y, then we'll have that common denominator. Likewise, the second term, it's missing y. It already has the x plus y, so it needs to be times y. So we multiply that by y over y. Does everyone understand this step? This is the key step. Yeah, Rosie, you're good?
Yeah.
Anna, you're good?
Yep.
Bella, you're good?
Yep.
Okay. Mark, you better be good. So now we just multiply. And look, you just have x times the quantity x plus y and 3 times y. And then both denominators end up to be y times the quantity x plus y. Okay? And then let's distribute through that x times x plus y. So you get x squared plus xy. And then 3 times y is just 3y. And now finally, let's do the operation in the middle, which is addition. So we'll add the 3y to the x squared plus xy. Remember, when you're adding fractions with a common denominator, the denominator stays the same. Notice that we distributed out the x times the quantity x plus y in the numerator, but we did not distribute out the quantity y, or I'm sorry, the denominator at all. It's a good habit to distribute the numerator out because you're going to add other things to it, and that will help you confirm that there are or not like terms, right? But either which way, the important part is getting to like getting to the end. Even if you have x times the quantity x plus y plus 3y, you would still have the right answer, just written in a more complicated form. Any questions?
No.
No.
Okay, let's do the second one. Anna, do you have any idea what a common denominator for the second one would be?
No.
It would
Would
be.
it be a plus b times x?
Yeah, but the quantity a plus b times x. Okay?
Oh, yeah.
Because you're multiplying the two denominators
Okay.
together. Again, that's just the simple way.
Both of them. Yeah.
If one denominator is not a factor of another denominator, then you would just do it this way. Okay? And so now, let's multiply by fractions equivalent to 1 so that we get an equivalent fraction. So the first one, x over a plus b, what's it missing? It's missing an x over x, right? It's missing an x in the denominator. To make that a factor equivalent to 1, it's just x over x. Okay? The second one, it's missing the whole thing. It's missing x times the quantity a plus b. It has no denominator. So you multiply x times the quantity a plus b over itself. Right? And the third term, b plus c over x, it's missing the a plus b. So you multiply that by a plus b over a plus b. Any questions? Like I said, this is the hardest step right here. If you get this step right, you've gotten the right answer. You just need to simplify it afterwards. Any questions?
No.
We're good? Okay, good. So now let's do the multiplication. So the first one, you get x times x. Second one, you get a times x plus, or I'm sorry, a times the quantity x. Ax times the quantity a plus b. And then you get the last one, b plus c times the quantity a plus b. And all of them have the same denominator now. Okay, let's simplify. X times x is x squared. And then let's distribute the ax through. So ax times a is a squared x. Ax times b is abx. Right? Yep. Notice that second term has a minus. So we're keeping that minus throughout. Don't forget about the minus. If you change that to a plus, you'll be wrong. Okay? And the last one is our fun friend that we learned in December, FOIL. So we have two different binomials that we're multiplying together. So first, FOIL F is b times a, which gives you ab. And then inner, which is a times c, which gives you ac. And then outer, which is b times b, gives you b squared. And then last, b times c gives you bc. Does that make sense to everybody? I had a little FOIL review in here for you. Are we good?
Yep.
Yep.
Okay, now you just combine them because you're adding and subtracting fractions with common denominators. So you just add or subtract the numerators. Notice that minus sign for the second fraction carries through to both. It's like distributing it. So you get minus a squared x and minus abx. And then you look through here, you find out there are no like terms, and so you're done. That's it. Any questions here?
No.
All good. Bella, you too?
Yep.
Okay.
Yep.
Good. That's it. That's lesson 52. Here is lesson 53. We're going to remind ourselves about overall averages. And in this lesson, we talk about average, we're talking about means. You know this. Remember how to find the mean, okay, of a number. Bella, how do you find the mean of a number?
By adding up all the numbers and then dividing by the number of numbers.
You got it. So in the numbers, look at the second bullet point there. We have 6 numbers. 3, 3, 3, 3, and 6 and 6. you would add the numbers together. So 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 6 is 18, plus 6 is 24. You add the numbers to get 24. You divide it by the count of the numbers. There's 6 of them. So 24 divided by 6 equals 4, right? Everyone agree that the average of those 6 numbers is 4? Okay, good.
Yes.
So another way we can describe this set of numbers is by saying the average of the first 4 numbers is 3 and the last 2 numbers is 6. Because that's right. If the first 4 numbers are all 3, then their average is also 3, right? And likewise, if the last 2 numbers is 6, then their average is also 6, right? Now, here's the key to this lesson.
Right.
When you hear a set being described this way, you cannot just take the average of the averages to get the overall average. If you were to average out 3 and 6, 3 plus 6 is 9. 9 divided by 2 is 4.5. 4.5 is not the average of the set of numbers. The average is 4. Okay? So, how would you find the average if you had that? Basically, if you remember, you divide the sum of all of the numbers by the count of the numbers, and that gives you the average. If you know the average and the count of all the numbers, you could multiply those two together to get the sum of the numbers. So in the last problem, the average of the first 4 items is 3, so the sum of those items must be 12. Because then if you consider, if you continue on to find the average, 12 divided by the numbers is 4. I'm sorry, 12 divided by the count of the numbers is 4. 12 divided by 4, the count of the numbers, equals the average, which is 3. Does that make sense?
Yeah.
So
Yeah.
likewise, the average of the last 2 items is 6. So the sum of those items is also 12. So to find the average, simply divide the sum of all the items divided by the count of all the items. In this case, the sum of all the items is 12 plus 12, which gives you 24, and the count of all the items is 4 plus 2 is 6. Then you divide 24 by 6, and that gives you 4, which is the average. That makes sense?
Mhm.
Yep.
So, it's easy to remember if you remember that, to find an average, you need to find the sum of all the numbers and divide that by the count of all the numbers. Then use what you have to figure out what the sums are and what the counts are, and then do the division. But I think we can do this. This isn't that bad. So here's an example problem for this. Jane averaged 85% on all 6 of the math tests and 95% on the 3 projects. What was her overall average? So remember, we need to find what her total percentage or total was for the 6 tests and the total was for the 3 projects. So 0.85, which is the same as 85% times 6, gives you 5.1. 0.95 times 3 gives you 2.85. Right? And then how many total assignments were there? There were 6 and 3. There were 9 total assignments. So you add up 5.1 plus 2.85, you get 7.95. And then you divide that by 9, which is that total number. And you get 0.883, which rounds to 88%. Does that make sense?
Yep.
Yeah.
So, and you can use logic to kind of think of this, that there were 3 more tests than projects. There were double the number of tests than projects. So the 85% is going to be counted twice as much because there's more of the 85%. Think of like a scale where you put 6 things on the 85% side and 3 things on the 95% side. Right? And so since you have more things on the 85%, your answer should be closer to 85 than to 95. And so looking at it, 88 is definitely closer to 85 than to 95. So that makes sense. If you'd gotten an answer of like 94, then you'd probably want to go back and figure out if you did anything wrong.
Mm-hmm.
Make sense?
Yeah.
Okay.
Yeah.
Cool. Actually, that was the end of that lesson. Let me stop the recording and then I'll do the other